want to select a script program. I'm going to call mine test 1. Then right click it and select edit. This window you have a bindings property window, which is coming from Struxureware, and you will find that if you right click the program component and select edit bindings, and you will see that this window is the same window that gets shown here. Up at the top, you can select this and you can import program files as plain English, which was the Andover Continuum script language, which is not what we are learning today. It's not used in Struxureware and B3 script programs. It was used only for the Andover Continuum Infinite line of devices. So, and here you have an export button, you can print, etc. Here you can decide what windows get shown, etc. As you create binding variables, they will show up here, and binding variables will also show up here in bindings as new variables. As you can see right now, we only have what are called system variables, which was the first topic we were going to touch. Here are the properties of this program component. If you go to bindings, you can bind to any of these properties. So if you wanted to bind to the TS, you could drag and drop in Struxureware, not here in the editor, but you can drag and drop, and then you could bind values from or to Struxureware into any of these system variables. Here's, for example, scan error, scanned. Scan is how long it takes the program to scan through every single line, and basically it's the execution rate time of the program, the type of program. All B3 programs will always be looping, but in Struxureware, this is a program object created in Struxureware, not in a B3 controller. Hence, these are configuration settings that do not apply, at least not all of them, to a B3 controller's program's object properties. Execution precedence is another property that applies only to Struxureware program objects. By changing this number, if you have multiple programs running at the same time, you can specify essentially which one of them will execute first. The flow type, this program could read through all the instructions and then go back to the top and read them again and execute those instructions over and over and over again. That would be a looping flow type of program object, whereas a fall through would execute only once when triggered, and once it finishes reading and executing all the lines, it will not try to go back to the top and execute again. This would be where you'd create those triggers and bind to them from Struxureware, and we have no references. So again, if we go back, you'll notice that if we had any data here, we would be able to bind to the system variables. If you open up the properties for this program, you can see the same properties that you were able to see in the script editor here in Struxureware. So as of right now, we only have system properties. We have got a line start time, we've got a scan time, we've got the status of the program. This is time in days, time in hours, time in minutes, and time in seconds. And essentially these variables, when they are declared, they don't need to be declared because they are part of the program, but when they are used, when they're called and queried for their current value, it'll apply to the line in which they're called, and it'll tell you how many seconds you have been and how many seconds you can use it in a statement to say, keep me here for this many seconds, minutes, hours, or days, and then move on or go to this other line of code. And that's typically how they get used, and we'll see that as we progress through the training. So anyway, this is just a pretty it's how the program looks without any user-defined variables, only system variables. So moving on, we'll begin to create values here in Struxureware, values that we will go ahead and bind to later in the program. We will do some bindings to user-defined variables and system variables. We'll see how that works. So first thing we need to do is get on this and select new. And we could make a new folder, but let's just go straight to making new values. So these are the different types of values you can have. You can have an analog value. We'll call this AV1. Okay. So there we go. We got 4 AVs. Now we'll go ahead and make a digital value. We'll make a multi-state value. Well, just to maintain object names in BACnet, we'll call this BV, binary value. So you got analog values, binary values, and multi-state values in BACnet. These are the data types that conform to BACnet as well. All of them except for these last two. So we've got a string value. We'll call this str1. There is no string, at least not that I know of, no string value object type in BACnet or timestamp. At least not that I know of. So we'll call this datetime 1. So up here you can right click and select what columns to add. For now we'll just want to see values here. So these are default values. Get rid of description, completely unnecessary. And this is how Struxureware initializes its different types of data types. So what is a data type? and what it's how is data interpreted in these kinds of systems? Well, the quick and short would be a variable is a container. In memory, you have a big chunk in random access memory used by applications in Windows operating systems. You have a huge number of zeros and one. Programs allocate by using standard data types. They allocate memories with an address so that they can reference that variable and the value it stores inside. So the other thing that a data type addresses is not only the logical address of this block now, so that the application possibly running here knows where to go get this information that is in here. This would be the application. The other thing that also gets specified here is the size of this data block. How many bits of memory can we store in this data type before we overflow it and cause some kind of error. There are obviously different types of data type. There's a if this was, for example, a number type of data, this would be a Boolean type of data. Booleans only require two states, true and false. Hence, you can do away with one single bit. Therefore, the Boolean is likely to be the smallest data type you will find, whereas, for example, you could have something like a string, which is a data type that can grow. It doesn't have a specific size. It has a variable size. Same thing as arrays, which we will see. Arrays, you do have to specify its size in the program. How many elements is the array going to have? Same thing with the string. You have to specify at runtime the size of the string, how many characters, how many ASCII characters you're going to have in your string. But the fact is, unlike a number, which is always 32 or 64 bits, or a Boolean, which is always 1 bit for true or false, 0 or 1, a string or a array data type does not have a fixed length or size. By standard, it's defined by the user when it's created and declared in a program.